Hello Year 12 and welcome to the third of these videos for our topic on trig functions. So the first of the videos, we looked at radians, how to determine them, and some exact values including angles of any magnitude, obtuse and reflex angles in particular. In the second video we looked at the mensuration of arc lengths, sectors and segments. We calculated those areas and we did so using radians, which led us to some more straightforward formulas than the formulas we've used before, but nonetheless not terribly different. We're going to look at the graphs of trigonometric functions now. So now we are interested in trigonometry as a periodic function, as a function that sort of changes but repeats as well, right? That comes back, which is a bit different to most of the other functions we've looked at before. Right, so you can see that this is going to be good for modelling things like vibrations or waves or fluctuations in temperature, perhaps throughout the day, or all sorts of things, right, that these become an interesting new type of function for us to work with. Call it a periodic function. And there is some terminology that comes with this. Mostly we are going to be looking at sine and cos, right, that form these sort of waves. Tan has regular vertical asymptotes, as do all of our inverses. So all of our inverses in sense, so cosec, sec and cot. Okay, because of course every time one of our three basic functions here, every time that's equal to 0, every time it crosses the x-axis, and they all do that frequently, right, the inverse of 0, or the reciprocal of 0, reciprocal functions, 1 over 0 is undefined. So every time we have a 0, here, here and here, right, the corresponding reciprocal function will have a vertical asymptote. But as I said, sine and cos are the ones we're the most interested in here, generally. So it's good to understand those. Now, new word, amplitude. Really what the amplitude is, if I can come back here, this is the amplitude. That's the height of the wave from that centre line. Also sort of depth of the trough, or nadir, if you will. Right, the amplitude is how far from that centre line the function manages to get. We can't describe the amplitude of tan, right, because it increases infinitely here and down there. So I guess we could sort of almost say that it has an amplitude of infinity, but really amplitude is only for waves, where it wobbles back and forth. So that's the amplitude. Now we can vary the amplitude of a function by putting a constant coefficient in front of the function. Okay? So, if I have function x sine x, or y equals sine x, it has an amplitude of 1. Y equals 2 sine x has an amplitude of 2. Y equals 3 sine x, an amplitude of 3, and so on. Now, the next up is the period of a function. I referred to these as periodic functions before because we get that repetition. The same thing happens again. The period is how frequently the same thing happens again. Come back to sine and cos. If we look at this point here, right, on my graph, what I'm doing, I've got a positive gradient there. You can see I'm on the x-axis, and I've got a positive gradient and what would seem to be a point of inflection, right, from a concave up here to a concave down there, right, point of inflection there on the way up, right, still positive first derivative. So when does that next occur? Not now, right, I'm not on the x-axis, right, I've got to be on the x-axis. I'm back on the x-axis, but now I have a negative first derivative. I'm going downhill, so not here. Not here, back to the x-axis. Right, we can see that this point here matches this point here in so many ways. Right, this is one full cycle of my curve. right? And that occurred between 0 and 2 pi. So my period is 2 pi. Right, we can see every time I move by 2 pi, if I go 2 pi back here, I get to that same point again. Now it could be, I could go from pi on 2, if I increase that by 2 pi, I get 5 pi on 2, right? And again, you see that's my crest there. Right? My period here is equal to 2 pi. And if I were to vary this, the way that I vary the period of sine or cos is I change the coefficient of x, not the coefficient of the function, but of x. So here we go, if I have something like cos x has a period of 2 pi, but if I had something like the sine of 3x, its period is 2 pi over 3. Right? I take the coefficient of x and I divide 2 pi by that coefficient. It gives me the period of the function for sine and cos. Right? They are very similar. Tan is a little different. If we come back to our graph tan function here, right, let's consider this point here in the middle. When does that next occur? 0 and a pi, 2 pi and 3 pi, negative pi, negative 2 pi, negative 3 pi. This is repeating much more frequently. Tan has a frequency of 1 pi. Tan has a frequency of 1 pi. The reciprocal functions all have the same period. Tan's period is pi. And again, if I have something like tan 7 pi, no, tan 7x, the frequency of, the period of tan 7x is pi over 7. Not 2 pi over 7 as it was for sine and cos, just pi over 7 to make up for the fact that the period of the original function is shorter. Now let's apply some of these little understandings here to this sketch here. This is going to be it for the topic. Oh, not for the topic, for this video. Sketch the graph of y equals 4 cos 3x over 2, the domain from 0 to 2 pi. Now first of all, I have an amplitude of 4, so it's going to go up to 4 and down to negative 4. Great. Now my period here, right, for cos, it is 2 pi over this, my period, equals 2 pi over 3 over 2 equals 4 over 3 pi, 4 pi over 3. That's how often it recurs. Another way that we can look at this is, right, so starting at 0 to 2 pi, how many times does 4 over 3 go into 2? Right, 4 over 3 goes into 2 1 2/3 of a time. Hang on. No, it doesn't. 4 over 3 goes into 2 1.5 times. Okay, goes into that 1.5 times. So in fact, the reason I want to think about that is between 0 and 2 pi, I should get 1.5 full cycles. I find it much easier to sketch the curve first and then to draw the axes and intercepts in afterwards, mark those afterwards. I know I need 1.5 full cycles. I know that cos 0 is equal to 1. I'm going to start up high. Alright, it's not equal to, so I'm going to have an open circle. Cos is going to go here. No, not like that. Going to go here, down, and back up. There's my 1.5. Righto, 1.5. My axes go here through the middle and here. Okay, so there's my x-axis. my y-axis. That is at 4. This here is at -4. Now that's my 2 pi there. So this should be the halfway point here. That's pi. And that's pi there. This should be pi over 3. Pi over, the pen's not working very well. It's pi over 3 there. I also have 5 pi over 3 at that point there. Right, I can put my stationary points into, I suppose, but that looks pretty good. Right, and the video's blowing out, so there we go. That is graphs of trigonometric functions. Have I got another one there? Nope, that's great. Look, I think that's pretty good being able to sketch that much of it. We have looked at radians, we've looked at measuring arc lengths and areas. Now we have looked at the graphs of these functions. Right, if you've got any questions, hit me up.